Recently, we talked about all of the different things that we see in real life using percentages, especially in applications with money. And we made this list, and down at the very bottom was this word interest, and we had put two little stars next to it, and I let you know that we would be talking about interest during a different lesson. Well, this is that lesson. Today we're going to be talking about interest. Now, before we get started, you can start writing down this definition, and while you do that, I want to explain a little bit about what interest is. If you take money and put it into a savings account, certain banks will give you a percentage, kind of as a bonus or an incentive, for you to keep your money there. And they'll tell you that your money is going to earn a certain percentage, and that's going to be this rate here. And so the longer you keep your money in that account, the more it continues to build that money that the bank is paying you as a bonus. Another time that you will see interest is if you borrow money to buy something. If you borrow money to buy a car, there will be an interest rate. If you borrow money to buy a house, there will be an interest rate. And so the longer that you keep the money, the longer that it takes you to pay it back, the more you end up paying. It's kind of like a penalty. So the formula for simple interest is interest equals PRT. P stands for principal, which is the original amount of money that you put into the account, or the original amount of money that you borrowed. The R stands for the rate, which we're going to need as a decimal. Now they're going to give this to you as a percent, so we're going to have to change it. And the T stands for time, and that's going to be time in years. So then there's something else called compound interest. Now compound interest is a little bit different. Let's say that I started out with $100 in my account and that they were giving me 5% interest. Well, that means if I did 100 times 0.05 each year, I would be earning $5. So now I don't have $100 in my account, I have $105. So the following year, they're going to give me 5% based on that $105, not the 100. So in other words, I'm not earning $5 every year. The amount that I earn is going to go up a little every year because there's extra money in my account that I have earned. So this equation is a little bit more complicated. It's got the same components. P stands for principal, which is the original money. R stands for the rate. They're going to give you the rate as a percentage, and we'll change it to a decimal. And T stands for time in years. Now this one is weird because it has this quantity, 1 plus R, and it is raised to the T power. So when we do these calculations, you guys will be using a calculator to do these calculations. This is not something I would ask you to do by hand. So let's look at what the difference would be between these two different ideas. Let's say that you have $800 and are going to put this into a savings account for 5 years at 4%. Find out how much you will have in your account if your account used simple interest and then if it was using compound interest. So P stands for principal, R stands for rate, and T stands for time. Well, the time is 5 years. The rate is 4%, but I need to change 4% to a decimal. And remember, I do that by moving twice, 1, 2. So that's going to be 0.04. And the principal, the amount of money I originally put in, is 800. So I need to do 800 times 0.04 times 5. I can do that in any order that I want. I'm going to do 0.04 times 5 first. I know that 5 times 4 is 20, and because of that decimal, it's going to end up being 0.2. So I did that first just because it That seemed the easiest for me. You can do this in any order that you want. Now that I have that, I can multiply my 800 times 0.2. And I know that 8 times 2 is 16. And so it would be 1600 with those two zeros, but then the 0.2, the zero would move one time. So it's actually 160. So I put $800 into this account. I'm being rewarded with $160 in interest. So after 5 years, this account will have $960 in it. Now on this side, you remember that I said that we would be using a calculator. We're going to get this set up first. The P stands for principal, which is 800. And then I'm going to have 1 plus the rate. The rate was 4%, but we turned it into a decimal, 0.04. And this exponent up here, t for time, that's 5 years. So 800 times, what's 1 plus 0.04? 1.04. So I'm going to get my calculator and do 1.04 to the 5th power. Now, I'm actually not sure if this calculator has, it does not. So we're going to have to do 1.04 times 1.04, that's 2, times 1.04, that's 3, times 1.04, that's 4, times 1.04. The calculators we use in class will be better than this. So what I just did was 1.04 to the 5th power. Now I have to take this number, this is what I just did, and I need to multiply by 800. So multiplied by 800. $973.32. So in this count, $973.32. You can see that with compound interest, you end up with a little bit more money. It's not a huge amount here, but if these numbers were any bigger, like if this was a bigger number, or if our percentage was bigger, or if we were leaving the money for a longer amount of time, the difference between these two accounts would be much greater. On this game, you will be counting out the correct cash from a cash drawer for the interest problem that you see on the screen. tinyurl.com/carnesinterest.